Hello students, this is Anchal Kamra. Today we are going to discuss about basics of data structure. So let's get started. A data structure is a specialized format for organizing, processing, retrieving and storing data. Think of it as a blueprint of how information is arranged in computer memory, enabling efficient access and modification. So what it wants to say is that data structure is nothing but a structure with which we are deciding what how the data would be stored, right? So how it is being stored, that is being decided by the data structure, so that the performance and the scalability of the application can be directly linked with that. According to the application that we want to use, or we want to work in, based on that we are going to choose the data structure, right? So there are basically two types of data structure. One is linear, another one is non-linear. Now, what is linear data structure? The elements are arranged sequentially, forming a straight line. Each element has a unique predecessor and successor. That means वो डाटा स्ट्रक्चर जिसके जो एलिमेंट्स है दैट इज इन अ स्ट्रेट लाइन, एंड उस एलिमेंट के पीछे भी एक एलिमेंट है, उसके आगे भी एक एलिमेंट है, दैट इज इन द फॉर्म ऑफ अ लाइन. So those data structures are called as linear data structure. But on the other hand, non-linear data structures are what? Which are not arranged sequentially. Instead, they can connect to multiple elements, creating complex relationships just like trees and graphs, right? So in this lecture, we are going to discuss all the linear data structures, which are arrays, linked list, stack, and queue. Now, what are these? Arrays is what? Arrays is a collection of items of same data type. That means if we are taking elements of integer type, all the elements have to be of type int. If we are taking elements of character type, all the elements have to be of character data type only, like that. On the other hand, if we talk about linked list, in this, the elements are being stored such that the data part of one node is pointing to the next node, and this is the way how the elements are being linked. But on the other hand, in arrays, all the elements are stored in a contiguous memory allocation, but in case of linked list, the elements are stored in scattered, or you can say distributed manner. That means the elements can be, this is one element of linked list which is called as node, this is another element, this would be some another element, and these elements are scattered in the memory, they are not at one place. But in case of arrays, all the elements are stored in contiguous memory allocation. So if the starting address of, let's say, starting address of the array is 1000, all the elements would start from 1000 and are being stored till the end of the array. But in case of linked list, only one node is stored at, uh, only one node would be stored at one time, or the another element would be stored somewhere else in the memory, right? Now, what is stack and what is queue? Stack is based on the concept which is last in first out, and queue is based on the concept first in first out. Stack is something like stack of plates, कि एक के ऊपर एक प्लेट रखी हुई है. अगर आपको नई प्लेट इस स्टैक के अंदर रखनी है, तो आपको सबसे ऊपर ही रखनी पड़ेगी. अगर आपको डिलीट करनी है, लेट से आप ये पर्टिकुलर प्लेट को रिमूव करना चाह रहे हो, तो आपको ये तीनों प्लेट वन बाय वन यहाँ से रिमूव करनी पड़ेगी, इसको डिलीट करना पड़ेगा, देन उन्हीं प्लेट्स को वन बाय वन फिर वापस इकट्ठा यहाँ पे रखना पड़ेगा, वन एट अ टाइम. ऑन द अदर हैंड, इफ वी टॉक अबाउट क्यू, तो इंसर्शन एंड डिलीशन अलग अलग एंड से होती है, कि एक आपका फ्रंट एंड होगा, एक एंड आपका rear end होगा. We are going to discuss in detail queue later on as well. But what I'm trying to say is कि queue represents a ticket counter queue. That means suppose there is a ticket counter over here, and there are people standing in a row in front of the ticket counter. So this is the very first person, this is second person, third person, and so on. So अगर कोई नया person आएगा in order to stand in the queue, that person needs to enter from here. अगर किसी ने ticket अपनी buy कर ली है, then that person is gonna leave the queue from this end. So insertion and deletion are done from different end, right? So let's discuss arrays now. What are arrays? Arrays are among the simplest and most fundamental data structure. They are crucial for organizing data when you know the size of your collection in advance. So arrays के जो basic point है, that is, firstly it is having fixed size. You can't change the size of arrays dynamically. It is sequential collection of elements of the same data type. Firstly, data type has to be same, or you can say homogeneous collection of items is there. Then we have continuous memory allocation, right? Direct access to elements can be done by writing a of 0, a of 1, or array of 0, whatsoever the name of the array is, followed by the subscript. Elements stored in contiguous memory allocation. How we use arrays? Strong lists of items like exam score, names, or pixel values. These things are being stored in arrays. Now, how array looks and what are the ways how we can declare an array, and we are going to discuss everything. So, if suppose there is an array of integer, so the statement should be int a of 5. That means we are instructing the compiler that we are declaring an array of type int with size 5 with the name a, right? This is nothing but a array. Now, as we know, one element of integer is of 4 bytes. Then 5 elements would be of what size? 4 into 5, that means 20 bytes. So by writing this statement, what we are instructing the compiler, that compiler would be assigning 20 bytes of memory, that too in a continuous manner, and that 20 bytes of memory would be given a name a. I am having a array over here. Elements are 5, 10, 20, 25, 30, and 35. There are total 6 elements, right? Suppose it is an integer array. So if one element of int is of 4 bytes, so 6 element would be taking how many bytes? 24 bytes. Now, if the first element, suppose, is having address 1000, the first address of the array is also called as base address. So if the base address is 1000, then the second element would be stored at what location? 1004. This element would be stored at what? 1008. Next would be stored at 1012, then 1016, 1020, and the array would end at 1024. That is the last address, right? This is how arrays are being stored. The index value or the subscript of array starts from 0 till size n minus 1. So if the array size is, let's say, a of 6, then array elements would be from index value 0 to index value 5. So how we write? We write the arrays like this. Suppose I want to change the value of a of 0, so I can just execute this. After execution of this statement, the array element would be changed or updated like that. These are the very basic operations of arrays. On your screen, you are visualizing 1D arrays. Along with that, we have 2D arrays as well, which look like the matrix of elements. You must have learned matrix in your mathematics subject. So it looks something like this. For 2D arrays, we need to have two subscripts. Let's say the size of array is 2 rows. The first subscript is defining rows, the second subscript is defining number of columns. So this array would be having 2 rows with subscript 0 and 1, and 3 columns with subscript 0, 1, and 2. As you know, the index values in arrays start from 0, and it goes till the size n minus 1. These were the very, very basic idea of arrays. I'm repeating once again what are arrays. Collection of same और homogeneous data type. That means कि एक एलिमेंट का अगर डाटा टाइप इंटीजर है तो सारे इंटीजर के होंगे, अगर एक फ्लोट है तो सारे फ्लोट के होंगे, राइट. एंड मेमोरी एलोकेशन क्या होगी? कंटिगुअस मेमोरी एलोकेशन, दैट इज इकट्ठी मेमोरी होगी. अगर आपका पहला एलिमेंट 1000 पे है तो इंटीजर का अगर एरे तो दूसरा एलिमेंट 1004 पे होगा एंड सो ऑन. दिस इज द वे हाउ द एलिमेंट्स आर बीइंग स्टोर्ड, right? Now let's move to the next data structure, and that is linked list. In linked list, the elements are stored in the form of nodes, and nodes look like this. There are two parts in the node. First part is holding data. The second part is holding pointer or address to the next node, which is also called as next, right? As it is represented over here. Now, linked list, unlike arrays, can change size dynamically. As you know, in case of arrays, the size is fixed. You can't change the size of arrays, right? If the array is having, let's say, a of 6, only 6 elements can be stored. You can't increase or decrease the size of the array in between the algorithm. If you want to do, there are a few options, like you can use malloc and calloc, that is the dynamic memory allocation methods. But if you're not using those things, you have to use linked list. That is the data structure which is handling the disadvantage of arrays. Linked list can change the size dynamically. You can do insertion and deletion dynamically कि अगर 10 एलिमेंट है आप 10 से 8 कर दिए आप कर सकते हो, 10 से 12 कर दिए आप कर सकते हो dynamically. You can increase and decrease the size of linked list. अब लिंक लिस्ट के जो एलिमेंट्स हैं वो किस तरह होंगे? इट इज इन द फॉर्म ऑफ नोड्स which is further having two parts. One is data part, another one is pointer part. Data part के अंदर आपका एलिमेंट या डाटा स्टोर होगा. जैसे इस एग्जांपल के अंदर क्या है, कैरेक्टर का हमने डाटा स्टोर करा हुआ है ए बी सी डी. एंड पॉइंटर टू द नेक्स्ट नोड इज हैंडलिंग व्हाट? इट इज होल्डिंग एड्रेस ऑफ द नेक्स्ट नोड. सो हाउ इट लुक्स कि सपोज द एड्रेस ऑफ फर्स्ट नोड इज 1000, address of second node is 5000, third node is having, let's say, 2500, next is having 500. So the data part of first node would be holding what? It is holding 5000 because it is referencing or connecting, or you can say pointing to the next node. So address of next node would be stored in the data next part or pointer part of the first node. अब सिमिलरली थर्ड नोड का जो एड्रेस है वो सेकंड नोड के पॉइंटर पार्ट में आएगा. फोर्थ नोड का जो एड्रेस है वो थर्ड नोड के पॉइंटर पार्ट में आएगा. अब फोर्थ नोड का जो, इस एग्जांपल के अंदर हमारे पास जो फोर्थ नोड है दैट इज एक्टिंग एज द लास्ट नोड ऑफ द लिंक लिस्ट, एंड लास्ट नोड ऑफ द लिंक लिस्ट इज होल्डिंग नल इन द पॉइंटर पार्ट बिकॉज इसके आगे कोई एलिमेंट नहीं है टू शो कि इसके आगे कोई एलिमेंट नहीं, दिस इज द लास्ट एलिमेंट, हम वहां पे नल पॉइंटर को प्लेस करते हैं. अब ये सारे नोड्स तो आपस में कनेक्ट हो गए, बट हाउ we can traverse the linked list or how we can traverse a data structure. So for that, in order to process anything that is updation, deletion or insertion, इनमें से कुछ भी काम करने के लिए हमें क्या चाहिए? We need to move from the very first element till the last element of the linked list. In order to do that, we have a pointer which is called as head or start pointer, start or head pointer, which is holding address of the first node, right? So start or head is pointing to the first node is pointing to second, second is pointing to third, third is pointing to fourth, and in the fourth uh, node of linked list we are having null in the pointer part. Now the definition is the linear collection of data elements called nodes where each node points to the next node in the sequence. Now characteristics are nodes can be scattered throughout the memory. That's why we can change the size of linked list dynamically, क्योंकि कहीं पे भी कोई भी नोड हम नहीं क्रिएट कर लेंगे. सपोज करो कि हमारी एक नोड 5 बाइट ऑफ मेमोरी की है, इट कैन बी एनीथिंग, मैं एक रैंडम वैल्यू ले रही हूँ. अगर एक नोड 5 बाइट के तो हम कहीं पे भी 5 बाइट का एक मेमोरी लोकेशन उठा के बोल देंगे कि ये हमारी नई नोड है और उसको पॉइंटर से कनेक्ट कर देंगे टू द लास्ट पार्ट कि सपोज देयर इज वन अनदर न्यू नोड। अब हम यहाँ से नल रिमूव करके क्या कर देंगे कि इट इज पॉइंटिंग टू दिस, इसके लास्ट पे हम क्या नल लिख देंगे, यहाँ पे अपना नया एलिमेंट डाल देंगे एंड एड्रेस ऑफ दिस लेट्स से 5500 would be saved at this place. Now how insertion and deletion would be done in linked list वो हम later on discuss करेंगे whenever we are gonna discuss the linked list in detail. For now what you need to do is what you need to remember is कि linked list आप dynamically size change कर सकते हो, nodes memory के अंदर scattered है, दो हिस्सों में नोट बटा हुआ है, एक के अंदर डेटा पार्ट आएगा, एक के अंदर पॉइंटर पार्ट आएगा। Efficient insertion and deletion can be done because you can change the size dynamically. Implementing stacks and queues can be done with the help of linked list, although that can be done with the help of arrays as well, but this is one of the use case of linked list. Further, managing memory in operating system is can also be handled with the help of linked list. Now we are gonna move to the next, that is queue. This is our next data structure. अब queue के अंदर क्या है, queue model real world waiting lines processing task in the order they are received. This principle is fundamental in many computer science applications. Now what are the definition, what is the definition? A linear data structure that follows the first in first out principle. There are two basic principles, one is NQ, one is DQ. NQ is how you are entering the elements into the queue or how you are doing insertion in the queue. DQ is how you are deleting elements or removing the elements from the queue. Now how it is being done, so it looks something like that. जैसे मैंने अभी थोड़ी देर पहले आपको बताया कि टिकट काउंटर के आगे आपने लाइन लगाई हुई है, दिस इज द फ्रंट एंड, दिस इज द रियर एंड, और यू कैन सी इन दिस डायग्राम ओनली, ये आपका क्यू है, राइट, ये आपका फ्रंट एंड है, ये रियर एंड है। तो वेन एवर द एलिमेंट इज डी क्यूइंग, और जब एलिमेंट निकलेगा तो आपका फ्रंट से निकलेगा, जब एंटर करना होगा एलिमेंट तो आपका बैक एंड या टेल एंड या रियर एंड से होगा। सो NQ would be done from the previous side, that is the rear end, and DQ would be done from the front end, right? So that's why we say it works on first in first out. जो एलिमेंट सबसे पहले क्यू के अंदर गया होगा वही एलिमेंट सबसे पहले क्यू से बाहर भी निकलेगा, क्योंकि हम डायरेक्टली 5 को डिलीट नहीं कर सकते। अगर हमें डिलीट या डी क्यू करना है पहले हमें 3 को निकालना पड़ेगा, 4 को निकालना पड़ेगा, ओनली देन आई विल बी एबल टू डिलीट 5। So now I am moving to the next one, that is stack. Stack works on last in first out. It looks like pile of plates, जैसे मैंने अभी आपको थोड़ी देर पहले explain करा. You can only add a new plate on the top of other plate. You can only take a plate from the top of the stack, right? तो जैसे ये अगर empty stack है, अब दो चीजें हैं इसके अंदर, दो बेसिक ऑपरेशन है, पुश एंड पॉप। पुश इज एडिंग समथिंग टू द स्टैक, पॉप इज पॉपिंग आउट समथिंग फ्रॉम द स्टैक। सो पुश इज adds an element to the top of stack, removing pop is it removes the topmost element of the stack. So अगर ये empty stack है, अगर element add हुआ तो आपने सबसे पहले top of the stack पे वो element इंसर्ट कर दिया। टॉप ऑफ द स्टैक 0 से हो गया 1, और फिर नॉट फ्रॉम 0 टू 1, एक्चुअली फ्रॉम -1, जब आप स्टैक को इंप्लीमेंट करोगे तो यू विल गॉट टू नो कि टॉप ऑफ द स्टैक इज अ वेरिएबल विच इज टू बी केप्ट so that we can have a track कि how many elements are there in the stack। तो सबसे पहले स्टैक यहाँ पे होगा -1 पे। अगर आपने एलिमेंट एंटर करना है तो पहले आप इसको इंक्रीमेंट करोगे, -1 से ये होगा 0, तो 0th लोकेशन के ऊपर आप एक एलिमेंट इंसर्ट कर दोगे। फिर दूसरा एलिमेंट इंसर्ट करोगे, दूसरा एलिमेंट इंसर्ट करने के लिए इसको आप 0 से 1 पे मूव करोगे, नया एलिमेंट a ऑफ 1 के ऊपर स्टोर करोगे। फिर अगर पुश करना है तो इंक्रीमेंट इसको करोगे, टॉप तो स्टैक आ गया यहाँ पे, नया एलिमेंट AF2 के ऊपर आपने इंसर्ट कर दिया। अब अगर डिलीट करना है तब भी आप कहाँ से डिलीट करोगे? टॉप ऑफ द स्टैक वाला एलिमेंट ही आपका डिलीट होगा। सो व्हाट वी से कि जो एलिमेंट सबसे बाद में गया, जैसे 3 सबसे बाद में गया, लास्ट इन वही एलिमेंट सबसे पहले बाहर जाएगा। सो लास्ट इन फर्स्ट आउट इज द बेसिक आइडिया ऑफ स्टैक। Then what are the basic operations of data structure? One is searching. कि if you want to find one particular element from the data structure, be it linked list, stack or queue or arrays, तो अगर कोई एक पर्टिकुलर एलिमेंट ढूंढना है तो आप क्या करोगे? उस ऑपरेशन को हम नाम देते हैं सर्चिंग। कि सारे एलिमेंट से कोई एक ढूंढना है तो दैट इज सर्चिंग। अब कोई नया एलिमेंट ऐड करना है तो दैट इज कॉल्ड एज इंसर्शन। डिलीशन क्या होगा? कि कोई पर्टिकुलर एलिमेंट आपको डाटा स्ट्रक्चर में से अगर डिलीट करना है। अपडेशन क्या होगा? कि अगर कोई पर्टिकुलर एलिमेंट की वैल्यू को आपने चेंज करना है, इफ यू वांट टू अपडेट अ एग्जिस्टिंग डाटा एलिमेंट, दैट वुड बी कॉल्ड एज अपडेशन इन अ डाटा स्ट्रक्चर। एक वेरी वेरी बेसिक एंड द वेरी फर्स्ट ऑपरेशन यहाँ पे मैंने स्लाइड में मिस कर दिया, विच इज ट्रेवर्सल और ट्रेवर्सिंग इन द डाटा स्ट्रक्चर। Why it is not written? Because whenever you are doing searching, insertion या deletion, in all these cases traversal side by side हो ही रहा है। Traversal is what? Traversal is called as walking through the data structure. तो अगर आप एक पूरे डाटा स्ट्रक्चर में फ्रॉम द वेरी फर्स्ट टिल द लास्ट एलिमेंट आप वॉक थ्रू कर रहे हो एंड चेक कर रहे हो कि कहाँ पे कौन सा एलिमेंट है, तो दैट इज नथिंग बट द ट्रेवर्सल। अब ड्यूरिंग दिस वॉक थ्रू आप कोई भी एक टास्क परफॉर्म कर सकते हो, दैट इज साइड बाय साइड आप एक और चीज कर रहे हो, बट वॉकिंग थ्रू इज नथिंग बट कॉल्ड एज ट्रेवर्सल इन एन ऑफ अ डेटा स्ट्रक्चर। That's it for this particular lecture. In this lecture, what we have learned: what is data structure, what are different types of data structures, and intro to basic data structure was being done. So if you like this lecture, hit the like button, share it with your friends, and do subscribe to my channel. Thank you, students.